Hi, my name is José Eduardo Puentes Martinez, and this is the final stage of the key activity. So, first of all, Britannica defines coefficient of friction as the ratio of the frictional force resisting the motion of two surfaces in contact to the normal force pressing the two surfaces together. So what does this mean? Like it says, it's the force resisting the motion. So higher the value of the coefficient of friction, higher this resistance is going to be, and lower the value, lower the resistance of motion. Okay, so this is between the interaction of two surfaces. Now with this, we can create a base question. How does the coefficient of friction really interacts in the real world? We're gonna answer this by doing an experiment of sliding a toy car in an inclined table and measure the time it took. This table is going to have two different materials with two different coefficient of friction values. So we can see how this variation actually interacts in the real world. So the variables we're going to work with, the independent variable is the material surface. In this case, we're going to use two different materials, wood and cloth. This wood is a more polished type of wood, so it has a lower coefficient of friction value. And the cloth, it is a more rough cloth, so it has a higher coefficient of friction value. The dependent variable in this case is the time it takes to the toy car to travel all that distance, and also with the time we can get the acceleration or the velocity. And the control variable, in this case the angle of inclination of the table and the distance to travel is going to be the same. The only thing that is going to change is the material of surface. Okay, so for the methodology, the materials we're going to use is a toy car, rule, an inclinable table, the two different materials with different friction coefficient, a protractor to measure the angle of the table, and a timer to measure that time it took to travel all that distance. For the setup is pretty simple. We need to place one material over the client table and set the toy car to a measured distance from the bottom. In this case, it's gonna be it was 83 centimeters, so it has 83 centimeters between the toy car and the end of the inclined table. And for the execution, we only have to free the toy car and start the timer. And when the toy car gets to the end at the bottom of the inclined table, we need to stop the timer. And now we have measured the time it took to travel all that distance. Now we have to repeat the same exact same thing, but now with a different material. In this case, the second material, the cloth. Okay, so with this base, we can think that, like we said, lower coefficient of friction value, the lower the resistance is going to be. Okay, so if the resistance is lower, the velocity it might go higher. It should be going faster. Okay, so the results are the following. As you can see, I take 5 different attempts, so to get a more average time, because some variation that could happen, direction time, some things like that. So the average time, as you can see in the wood, to travel all the distance, the 83 centimeters, it was 1.23 seconds. In the wood, in the polished type wood, the lower value of coefficient of friction value. And in with the cloth, as you can see, the average time was roughly 2 seconds, well, 1.99 seconds. So it took more time to travel the exact same distance in the exact same angle of inclination, everything the same. The only thing that changed was the material of that surface of the table. So with an analysis, we now can check with the time and the distance. We have now the average velocity. We can calculate the average velocity and the acceleration of the toy car. As you can see, in a light blue, is the wood, and in a more darker blue it's the cloth. So first, the wood of average time, it took a lower time than the cloth. The cloth took a higher time to travel the exact same distance. And as you can see, the average velocity, since it's the same distance, the more time you take to travel a distance, the slower you go. So as you can see, uh, the car in the wood moved faster, and the car in the cloud moved slower. And the same with the acceleration. With the wood moved faster, the acceleration was higher, and with the cloud, the acceleration was lower. So yeah, like we expected, the higher the value of the coefficient of friction, the higher the resistance of moving it has. So in this case, the lower it moves, as we can see with the cloud. So yeah, to the base question, we have the base answer. It's a higher coefficient of friction interacts in the real world. How? By setting more resistance. In this case, it causes the toy car to move slower. Whatever is the case, higher the coefficient of friction of a surface means that any object will move slower. All this caused by the resistance is shown to slide, because as we remember, the coefficient of friction was force of resisting of moving. Okay, so more the resistance, more the volume, more the resistance, and it tends to go slower. So the implication with the experiment, well, there were various variables that affect the results of the experiment, but these variables were too little to show a different output that they accepted. In the real world, there are many other things that interact. Also, some measuring instruments were not the most exact ones. Like I used a timer, so it was a that latency of reaction time that it took me to start and stop the timer. But these changes were too minimum. The exactitude of the output varies by the minimum, so we have a very good general overview of how the coefficient of friction really interacts in the real world. So yeah, the bibliographical reference that I use for this work. And okay, so that's everything. Thanks for your time and your attention. Bye.